As the Soviet space probe Venera 4 got ready to land on Venus, scientists had only a vague idea of what to expect from this mysterious planet. They thought maybe, under all those clouds, Venus could be a bit like Earth, with a similar atmosphere and temperatures. But as it turned out, Venus had some surprises in store that nobody could have predicted. So, how did the Venera probe survive this grueling journey with limited technology in the 1970s, and what did they find on Venus? Stay tuned to find out. As it plunged into the atmosphere at a staggering speed of 40,000 kilometers per hour, the Venera 4 deployed its parachute and began transmitting data through its antenna. Initially, things seemed pretty familiar: similar atmospheric pressure to Earth and a balmy temperature around 30 degrees C. But as it descended deeper into Venus's atmosphere, things took a wild turn. The pressure skyrocketed from 1 atmosphere to 10, then 20, while the temperature soared well over 200 degrees C. Suddenly, the space probe suffered a catastrophic failure, and all contact was lost. The final transmission revealed an atmosphere a whopping 22 times denser and a scorching 250 degrees Celsius hotter than Earth's. Despite the setback, the Soviets were more determined than ever to conquer the challenges of Venus. The early space probes were quite straightforward in design. The lander consisted of a compact 1-meter-wide titanium sphere pressurized to around 25 atmospheres. Equipped with a few scientific instruments for atmospheric analysis and a battery for power during descent, its simplicity was its hallmark. Unlike modern probes, it lacked thrusters, relying instead on drag and a series of parachutes to guide it to the surface. However, Venus's dense atmosphere posed a unique challenge. Instead of swiftly descending through the atmosphere in a matter of minutes, Venera 4 encountered resistance akin to hitting a solid barrier, slowing its descent to a mere 18 kilometers per hour, much slower than anticipated. This posed a significant challenge for the spacecraft, as it had to withstand a grueling 90-minute ordeal inside Venus's atmosphere, enduring relentless heat and pressure until ultimately being crushed. Recognizing the time constraints once inside Venus's atmosphere, the Soviets understood the urgency of passing through before the lander succumbed to the extreme conditions. As a result, they completely re-evaluated their strategy for exploring Venus. They reached out to NASA, requesting a specialized heat-resistant material via fax. Unfortunately, the fax failed to transmit, leaving the Soviets to devise their own solution to the formidable challenges of Venus exploration. To expedite the descent and ensure Venera reached the surface of Venus before succumbing to destruction, the Soviets undertook a radical redesign of the space probe. They introduced a clever modification to the parachute, incorporating a cord that prevented it from deploying immediately upon entry into the atmosphere. This adjustment allowed Venera to plummet much more rapidly toward the surface. The cord was crafted from a material designed to melt at 200 degrees C, ensuring that the parachute remained closed until the probe was closer to its destination. Recognizing the uncertainty surrounding surface pressure on Venus, engineers took a cautious approach to Venera's protection, opting for robust over-engineering. The walls of the probe were doubled in thickness, and its structure was reinforced to withstand pressures of up to 180 atmospheres. With these enhancements, the Soviets prepared to subject Venera 7 to the unforgiving conditions awaiting it on Venus's surface. As the lander entered Venus's atmosphere, it slowed to a crawl and deployed its parachute, thanks to the cleverly designed cord that facilitated a swift descent through the thick atmosphere. For the first time, the probe was closer to the surface than any previous missions. However, with just 3 kilometers left to go, disaster struck as the parachute tore apart, causing the probe to plummet to the ground at a speed of 60 kilometers per hour. The Soviets feared yet another failure, but they were in for a surprise. Upon reviewing the data a few weeks later, they discovered a faint signal that had been transmitting for 23 minutes after the lander's impact. Astonishingly, the lander had survived the landing, albeit knocked onto its side, resulting in an extremely weak signal being sent to Earth. Despite the setback, the final data received revealed a staggering surface temperature of 500 degrees C. With the temperature now identified as the primary challenge limiting their time on the surface, the Soviets faced a new hurdle in their quest to explore Venus: the engineers devised a brilliant yet straightforward cooling solution for Venera 8. Within the space probe were blocks of lithium nitrate, a salt-like substance known for its exceptionally high heat of fusion. This refers to the amount of energy required to transition it from a solid to a liquid state. Heating up this material by just 1 degree C demands nearly 2 joules of energy per gram. However, when it reaches its melting point, the transition from solid to liquid absorbs almost 300 joules of energy. Consequently, this transformation from solid to liquid effectively absorbs a significant amount of heat energy, effectively storing it within the material. To utilize this principle for cooling, blocks of lithium nitrate were strategically placed inside the lander to absorb heat and draw it away from the electrical components. The cooling system proved highly effective, enabling Venera 8 to reach Venus and endure a full hour on its surface. With this success, the Soviets had seemingly mastered the art of Venus exploration. However, the world remained largely in the dark about the true appearance of this enigmatic planet. Thus, the responsibility fell upon Venera 9 to capture the first-ever images of Venus. For this mission, the lander underwent a complete redesign. Instead of relying on parachutes for the final descent, Venera 9 was equipped with a large air brake to decelerate its approach. Additionally, it featured a set of landing legs designed to absorb the impact upon touchdown. However, the standout feature of Venera 9 was its advanced camera system. Positioned on either side of the lander were 2 movable cameras capable of capturing a 360-degree panorama of the surrounding landscape. Yet, designing a camera resilient enough to withstand the extreme pressures and temperatures of Venus posed yet another formidable challenge for the engineers. The cameras were positioned within the pressure vessel of the lander, with 2 periscopes extending out into the incredibly thick pressure window. At the tip of each periscope was a small, rotatable lens capable of scanning a 180-degree view of the surface. Light would travel down the periscope and pass through a lens designed to correct for the distortion caused by the thick pressure window. Each camera was equipped with a large lens cap designed to eject upon landing. However, on Venera 9, only one of these caps functioned properly. Despite this setback, it marked the historic capture of the very first picture taken on Venus. Subsequent missions saw improvements to the camera technology, eventually enabling the capture of higher-definition color images. On Venera 14, an additional innovation was introduced with the inclusion of a microphone on board, further enhancing our understanding of Venus's environment. In total, the Soviets successfully landed on Venus 8 times, with each mission yielding remarkable images and invaluable scientific data about this enigmatic planet. This feat remains unmatched even half a century later, underscoring the pioneering nature of their achievements in exploring the mysteries of Venus. Thank you for watching. If you want to learn more about the wonders of space and the human efforts that have been made to unravel its mysteries, remember to like this video and subscribe to our channel.